Why does sphere surface area use calculus? Imagine trying to measure the surface of a perfectly round ball. It seems simple, but how do you find the exact area of its curved surface? That's where calculus comes into play. Calculus helps us understand shapes that are not flat or straight. When dealing with a sphere, the surface curves in every direction, making it tricky to measure with just basic geometry. A sphere is made up of all points that are the same distance from a center point. This distance is called the radius. The formula for the surface area of a sphere is 4 times pi times the radius squared. But deriving that formula isn't straightforward without calculus. Think about a semicircle, which is half of a circle. If you rotate this semicircle around its diameter, it creates a sphere. To find the surface area of this shape, calculus breaks the semicircle into tiny slices or arcs. Each of these tiny pieces, when rotated, forms a small band or strip. By summing up the areas of all these strips, we get the total surface area. Calculus uses a method called integration to add up all these tiny areas. It's like adding up an infinite number of small pieces to get the whole. The integral takes into account both the length of each tiny arc and how, for it travels around the axis of rotation. This is done through a formula that involves the function describing the curve and its slope at each point. For the sphere, the curve is described by the equation of a semicircle. When we apply the integral to this curve from one end to the other, it gives us the exact surface area. This process confirms the formula of 4 pi times the radius squared. Using calculus is essential because it allows us to handle the continuous curvature of a sphere. Basic geometry can't accurately measure the surface of a curved shape like this. Instead, calculus provides a precise way to sum up all the tiny surface areas, no matter how complex the shape. This approach is not just limited to spheres. It helps us find surface areas of all kinds of curved objects, from cylinders to more complicated shapes. It connects the idea of curves with the ability to measure and understand their properties in three-dimensional space. In real-world applications, knowing the exact surface area of a sphere is important in fields like physics, engineering, and computer graphics. Whether calculating heat transfer, designing materials, or creating realistic models, calculus makes it possible to get accurate measurements of curved surfaces. So, the reason calculus is used for sphere surface area calculations is because it provides a way to measure the total surface of a shape that is constantly changing direction. It breaks down the complex surface into tiny, manageable pieces and then adds them all up precisely. That's how we get the exact surface area of a sphere, and why calculus is such a powerful tool in geometry.